Good morning. Good morning to everyone. Okay. Okay, fine. So now, with respect to last class, can anyone tell me what we have discussed in the last class? Can any one of you? Hmm? What we have discussed in the last class? Fast. What we have discussed? Preparation of potassium dichromate from chromite ore. Yes, both Jahnavi and Narasimha, both are correct. So we have discussed about K2 Cr2O7, that is potassium dichromate, right? Then we have discussed about difference between chromate and dichromate, right? So we have discussed the difference between chromate and dichromate. So whatever I have written, it is potassium dichromate, right? Same even we have discussed about the chromate. Now, what do you mean by chromate, or why it should be called as dichromate? Hmm? That is because when we are talking about chromate, this is where we have the chromate, Cr2O4, right? So Cr4 minus 2, that is chromate. Cr2O7 minus 2, it is dichromate. So that's where we have the dichromate and chromate. So we have discussed about these two, right? Now when I am talking about these two, what is the oxidation state of chromium in both the cases? It will be +6. In both the case, chromium central atom, it is having +6 oxidation state. But still, potassium or sodium dichromate is considered as strong oxidizing agent. It will be considered as strong oxidizing agent. Okay, although chromium is in +6 oxidation state, highest oxidation state which can be attained by the chromium, that is +6. So that's why we have discussed about dichromate and chromate. Then briefly about their structure, right? Briefly about their structure. Then we have discussed about preparation of dichromate. So when it comes to preparation of potassium dichromate, what was there in step 1? This step 1, whatever we have discussed, you can skip, no problem. But whatever step 2 is there, then it will become step 1 in that case. Okay? So step 1 is concentrating of ore. Concentrating of ore. That's where we have the hydraulic washing or gravity separation. So that's where we have the step 1. So which is that ore? Chromite ore. So that is chromite ore, right? So we have the first step. So what is second step? Second step is, what is that second step?
Roasting of
Second step is roasting of the ore. Roasting of ore in presence of sodium carbonate, right? In presence of sodium carbonate. So that's where we have the roasting of ore in the presence of sodium carbonate. So what we are going to get here, we are going to get Na2CrO4, sodium chromate as the product. So we are going to get the sodium chromate as the product because we are going with the roasting. Since chromite ore where ferrous oxide will be there, that will become ferric oxide, right? So now since it is soluble, it will remain in solution, and whatever ferric oxide is there, Fe2O3, it will be insoluble. So naturally for the next step, it can be easily taken because one is soluble and another one is insoluble. Now what is step 3? That is conversion of chromate to dichromate. Next step is conversion of chromate to dichromate. How it will be done? What is that? What they are going to do? They are going to treat with the acid, right? So under acidic condition, chromate will be converted into dichromate, therefore in the presence of acid, right? So that's where we are going to get, and it will be a sulfuric acid which will be used. Jahnavi, yes, very good. So that's where yellow color of chromate will get converted into orange red color. Absolutely correct, right? So that's what we can observe. Now since we have used sulfuric acid, since sodium chromate we have taken, one of the product will be sodium sulfate, in which we are not interested, and another product will be sodium dichromate. And sodium dichromate is bit soluble compared to sodium sulfate. So therefore for next step, dichromate will move due to its presence in the solution. Sodium sulfate is bit less soluble. Okay. Now the last step, if you are talking about preparation of potassium dichromate, then we should go to step 4. If you are talking about sodium dichromate, we should stop here. Okay. So what is that? Treating of dichromate, treating with KCl. Okay, treating which one we have to treat? Sodium dichromate has to be treated with KCl. So that's where once again we are going to have the two products. One as NaCl and another one as potassium dichromate. Now here it is reverse. NaCl is more soluble and dichromate is less soluble. So therefore easily it will crystallize out and NaCl will remain in the solution. So that's where we have the total number of steps as 4. Now it is with respect to preparation of potassium dichromate. Now this step you may write or you may not write, anything is fine, but you have to mention one sentence that rest of the steps it is compulsory. So in that case, first sentence you should write it as commercial preparation of potassium dichromate or sodium dichromate. It will be from using chromite ore. That one sentence has to be there. Fine. So that's where we have the steps. If first step if you don't want to write, then step 1, step 2, step 3. It will become 3-stage process. Fine. So that's where we have the commercial preparation of potassium dichromate, which we have discussed in the last class. Now, along with that, we have discussed about interconversion of, we have discussed that these two molecules, which are those two, that is chromate and dichromate, right? Interconversion of chromate and dichromate. Right? Now how it will be done? Under, no, that is pH 4 equilibrium will be there. So now under acidic condition, chromate will get converted into dichromate. under basic condition, dichromate will get converted into chromate. Right? So that's what we have discussed. Potassium hydroxide or sulfuric acid. So that's what we have discussed. Same way, Mayank was telling about pH4. Yes, we have discussed about pH4. What is that? At pH4, these two molecules or these two ions will be under equilibrium. That means equal amount of these two will be present at pH4. All of you have understood? Now, how come this can be interconvertible? That is because common oxidation state of the chromium, that is +6. Fine? All of you have understood? Any doubt? Anything else we have left over? I think it's done. Okay? So shall we move to the next one? So next one is with respect to properties. Next one is with respect to properties of dichromate. Properties of dichromate. Now, all of us will know, many times you have told, dichromate will act as a strong oxidizing agent. It will act as a strong oxidizing agent. Fine. So that's what we have observed. It will be used as a oxidizing agent in many of the reactions. In organic chemistry and all we have discussed. So now the question will be, why it will be acting as a strong oxidizing agent? What is the reason? Why or what is the reason? Why this dichromate will act as a strong oxidizing agent? That also under acidic condition. That also under acidic condition. They will act as a strong oxidizing agent. Right? So that is one of the important property of the dichromate. They will act. So all